Hey everyone, I'm Neil. I work at Dbox as a partner, and I want to take you through a technique in Fusion. It's a way of dealing with cleaning up aerial footage and a series of techniques which allow for much greater control when working with moving footage. This can be either filmed footage to remove objects, cranes, paint things out, or add additional details to the footage, or help integrate CG. But you can also use this over final rendered shots to add more organic and natural looking details. So here are some examples of this technique. These are shots which have a significant amount of paint over, fixing construction, removing garbage, removing site signage, and even cranes which pass over everything. This was all done with no rotoscoping, and the end result is incredibly stable. The technique I'm going to cover today is cleaning up this shot, which includes removing the crane, which passes over so many different surfaces, which are at different angles and undulations. Once you can do something like this, you can do anything. This is pretty much as complex as it gets. I'm going to be making a lot of assumptions about the experience level of the viewer. Ideally, you're aware of node-based compositing, but maybe you don't understand what makes it so powerful or have a reason to switch from After Effects yet. I'm also going to be assuming a reasonable amount of experience in 3D software tracking. I'm not going to be going over modeling 3D work or tracking in detail. I'm using Fusion, but this will work in Nuke. I'm going to be covering what each tool is doing along the way, so you should be able to translate this to any package that you're familiar with. I'm going to be using Max as my base software, but again, you could use Maya, Blender, or whatever you prefer. The tracking has been done in Synthesize, but anything would do the trick. The tracking requirements are very simple on this, but it does need to be an absolutely rock-solid track. So let's begin. So this is going to be our starting point. It's a Max file with the track setup, the context model, and everything lined up to the XREFs. Basically, you need to be ready to render your final shot. I'm not going to take you through how to get here. We're going to jump straight into Fusion, but there's a few important things to keep an eye out for. So the first is that your camera needs to be a free camera, and it needs to be baked to keyframes, not linked to anything, no X-forms and no scaling. If you've scaled and linked your camera to things to get it into place, use a script to bake it down to a new one with keyframes. Your context model needs to be very accurate. Client and design team supplied context models are never accurate enough. I've never seen one that was close to good enough to line a camera up to. We always make our own if we're doing any camera tracking. When making your own, there's a pretty good chance that your first version of it will not line up to the footage. So you're going to have to get it close enough and then skip through the footage and modify it enough to get it completely accurate. You can see I was less concerned about these edges as they were on the back, but I made sure that this edge tracks throughout the whole footage because this front edge is going to be very important for creating masks. Skip through the footage and make sure it lines up through the whole shot, and if it doesn't, you're going to need to change something so it does. When checking this, don't just check it in the viewport. Render out a wireframe overlay that you can place on top of the footage. This one's slightly out of date. This was my first version of the context model. So you can see where it was out here, and you can see where it was out here. I moved this geometry and manually lined it up to the footage. It's also very important to have this wireframe overlay, as we can use it as a guide to see what to repair. One of the things we'll be doing is removing these cranes, and you can see we obviously don't need to remove anything which is going to be covered up by our CG. We only need to clean up areas outside of that. So this crane is mostly fine. Next up, your context model needs to be a sensible polycount, clean collapsed geometry, and you're going to want to name it all. This AMC, we have the resi behind, the ground plane, etc. Make sure each building is a separate object. Once you have all of this together, everything lines up, your track is tidy, and you've tested an overlay, then you're good to export. Take everything, and we will file, export, export selected. Everything can stay as the default settings. Press OK. You can just ignore all of those. So we have our new Fusion document here. We're going to import the FBX. And what we're going to do, because Fusion doesn't like huge units, we're going to scale the file units by 0.01. Take a look at the merge here. You zoom out. And everything's quite a manageable scale. And that's because we scaled it down. So here's our full scene and our camera. So now we're going to organize all of this, tidy it up a bit. We're going to get rid of these merges. We're going to figure out what everything is. I think that was a dummy, so we don't need this. Free camera baked we need. This is obviously our camera, the more important elements, and then we have all of our 3D models. We can delete that and start to organize this. And we're going to get rid of the point cloud because we don't need it. So one thing we also do at this stage, we are going to import our footage. Now, all the way through this whole process, we're going to work with the JPEG sequence. This JPEG sequence is an exact copy of the EXR sequence that we're going to switch to. First thing we're going to do to test this is we're just going to overlay all of this 3D data over the top of this footage, just to check that it's working. So we're going to take our camera, add a merge 3D. I'm going to bring the camera into it, and then we're going to prioritize the models that we're going to include based on the proximity to the camera. We're going to start with the foreground, but I'm going to add everything that's in the background, and then we're going to add the ground plane. So there's no real issue with adding as many of these as you need. I like to keep everything pretty spaced out. What this is going to allow us to do is break out masks from each of these merge nodes without really having to go down the whole chain. So to look at this and compare it to the footage, we actually don't want the ground plane. So we're going to quickly add a render 3D, pipe this in here. And because this renderer has this camera, it's going to pick that camera as default. We're going to select it anyway. It's a good practice to not leave it on default because at some point in the future, you may pipe a new camera into this. We can add a regular merge node, add the footage as the background. Note the resolution, 5760 by 3240. To the same. And I'm going to drop that in the foreground. Now if we drop the blend of this down to 0.5, we can check our alignment. Go through, make sure everything's pretty close. Obviously some buildings you might want to pull this other merge in, and then you can check this foreground building. Okay, so we have our 3D data organized and lined up, ready to work with. We'll just get rid of those. So let's get started. So we're going to make a copy of our camera because we need to do some modifications to it. First thing you're going to want to do is unlock it. Everything that you import as an FBX comes in locked. You can see this little padlock here. Something to keep an eye out for. I'm going to load this as an image input. And we're going to look at the camera. Enable the image plane. It's a little bit dark, so I'm going to change this back to solid. Next thing we need to do, go to the projection tab, enable camera projection. That's going to allow this camera to project this image out of it. Now it's time to build something to catch on. First thing we're going to cover, for the sake of simplicity, we're going to remove the 12 from the top of this. If we play this footage through, it moves quite a lot. The masking would be relatively simple, but it would still be kind of time consuming. It would require a lot of animation. We're going to create a background. Now, the resolution of this background needs to be high enough that when it captures part of this footage, you're not degrading the quality. I'm going to leave this at 1920 by 1080 because it's a very small portion of the footage. Then we're going to add that to the image input of a 3D camera. Now this 3D camera, And you can see we already have the image plane enabled, and we can see it here. So what we do then, add a replace material 3D node and feed this into the scene input. So now the scene input is ready to replace this material. I'm then going to add a new merge 3D. I'm going to add this as one of the elements. So now we can see everything lined up in the scene. Switch the lights back on. And what we want is to align that image plane with the top surface of this. So we can take our camera, rotate it, -90, and then we'll place it over the top. So I'm going to make a wider angle of view to catch the whole roof. We're going to bring this image plane closer. Okay, so that looks pretty close. So now that we have this image plane set up, we're going to create a new merge node down here. We don't need this scene that we just lined the camera up in. We're just going to take the replaced material straight down into it. And then we're also going to feed this free camera into it. And what that's going to do is it's going to be the camera which is projecting the footage onto this image plane down here. But because of the replaced material node, the image plane that we placed catches the footage as it passes through. So now if we play this footage, you can see this does not move. It's absolutely locked. You can see the surrounding area move underneath it, but it's very, very stable. So now we need to render this. It's going to be from camera 3D2. We need to enable lighting to get that to show up. So now we have this top-down view, and we can play the footage, and we can check for stability. So as you can see, this is now completely stable. It's not perfectly stable. It actually shakes. There's 2 big shakes in this. That's because my track isn't good enough. The camera movement does not match the footage movement, which is where these wobbles and inaccuracies start to show up. This can be a problem, but it's fairly minor here, so I'm just going to show you how to fix it as we go. Now, one thing that's important is we start to develop a visual language for how this is going to work. So we're going to go through and add some labels. This camera is going to get a name. It's going to be called foreground helipad. Down here, the render has already updated. It's going to be this, but we're going to call that foreground helipad anyway. And we're also going to add a note. This is all going to become very, very useful as we go. It's important to keep things well documented in Fusion. Now, the technique that I use to reassemble this is, rather than keep working from this down the chain and then figure out a way to bring it back, I break everything off too much further down. So let's do a quick underlay. So this is going to be our barrier. And then next to that, we're going to create a wireless link. We're going to drag that into it. So now we have a wireless link which matches the foreground helipad. Let's copy that, paste it here. Now we can pull our wireless link over where it's useful. Now, the reason for this is that we're going to be using the very same replace material input to then reproject this onto the scene. So we add a replace material. This input becomes the material input, and this becomes the scene input. Just going to keep that straight. Down here we have a merge 3D. Bring this in. And we're going to have another copy of the camera and the footage. But here we're going to make the footage black. So the plate is going to be 5760 by 3240. It's going to go to the image input of this camera. And that camera is going to go to the merge. And then we have the renderer 3D. Now this renderer, we're going to change the camera to the original camera. Okay, so then what we've created here, we have this black background going into a static camera, which is positioned above the top of the building. We then bring in the real camera, which is projecting footage onto its image plane, and we catch that on this top plane, and then we render that top down. Once that's rendered top down, we can then work on it, which we'll do over here. This is where we'll do all of our painting and fixes. And once all of our painting and fixes are done, we will merge the original camera and its image plane and render from the original camera. So now we have this little patch of footage which follows its original position. This background, we can pull the alpha right down to 0. And now this will lay over the original footage with no trouble. We'll set up another wireless link, which will be the source footage. It's going to be down here. And we're going to have a merge, and we're going to drop this renderer straight over the top. 5760 by 3240. Okay, so now to see this in action, what we're going to do, we're going to add the paint tool. I'm going to select the stroke tool. Very important to not select the clone multi-stroke or multi-stroke. Those are designed to work on single frames. You need to use stroke. Set this to clone mode. In stroke controls, you can see stroke animation all frames. That's very important. You can use a still source, which is quite useful if you're painting out cars. We're going to use a video source. So we're just going to take this and we're going to start painting. As you can see on the right in the actual video, it's starting to remove quite a lot. Now when we play this back, this is stable. And another really important thing to point out here is that because we used video as our source for the clone stroking, it still retains the noise pattern. It still moves and it still does everything it's supposed to. Sometimes when you use a static image, it loses the quality of the video and it becomes very hard to get that back. So now that this is cached, you can see that we've completely removed the helipad sign from the roof. So now we have our footage, it's painted out. Because we've painted something out and we're using footage from elsewhere, any of the shake or the wobble that you see here is completely negated, because as it shakes to the left, so does the source of the paint. So this isn't an issue. But what if we wanted to add an image? So if we take this smiley face I have at a transform, and then a merge, and take a look at this over here. Now it's really important that we use this transform to scale and position this. While in the merge you can transform and scale it, what we're going to be doing is tracking this. And if the scaling has been done in the merge, then you can't compensate for that. Regardless, use the transform node. We're going to get that where we want. We get that to the scale that we want so that we're nice and happy with it. We can do a few other things to that. We can blur it slightly. We can do a color corrector. Warmer, remove some saturation. and the merge, put that down to 0.5. So there's still the problem of the shaking. So what we're going to do is we're going to add a tracker. And then we're going to pick a point to use. Let's get that back to frame 0. I'm just going to use the tip of the wand here. It's good to pick a point that's as central as possible to the thing that you want to track. Let's just track forward from here. It's a very, very simple track. I'm just going to assume that did a good job. Now what we're going to do is we're going to add this to the tracker. The operation is going to be match move. It's going to be foreground over back. So now when we play this back, you can see in these pixels just to the side that the tracked motion is being applied to the new foreground layer. It's completely locked into place. Now that we have this transform node in front of the tracker as well, we can independently scale and move this around still without the shake being affected by it. Now this is really important because if you do that afterwards and then you want to change it, then it kind of messes up the track situation. So what if we don't want to apply the whole footage over the top? We're going to add a color curves. This is kind of a dirty way of doing it. But in this color curves, we're going to switch the red, green, blue off, take the alpha, set that to 0. Now the alpha is 0 everywhere except for our smiley face. So now we get back to our merge, we take our tracker, we add this to the foreground. Now when you add it, it's going to get a little bit brighter, and that's because it's in additive merge mode, which even though the alpha is 0, it's still adding some of what we can see here. So you just need to pull this down to subtractive. And now this merge mode only serves to add a smiley face, which follows the shake of the footage. So now we can come down here, come to our renderer and our merge, and we have our full clean plate with a smiley face on the helipad. It's absolutely stable and rock solid. There's no shake, no wobble. So you can see how this technique would be used to remove trees, add details, decals, add banners that hang down. Very quickly you can add quite a lot of detail, especially if you start to photo bash things and take parts from other bits of footage. So, on to the more complicated part. Okay, so here's where we left off. We have our raw footage on the left with the helipad intact, and then on the right, we've replaced the helipad. So now we're going to work on something more complex, which is these cranes. At some point, you're going to work on a helicopter track. You're going to think adding the building and the render to the footage is no big deal. That's going to be fine. You'll just render everything over the top. And then you'll get footage like this, where the cranes have been turned away and they pass through a huge amount of the background. One solution to this could be to replace this with CG, but this is kind of a huge area and that would take a very long time. If it was over grassland or trees, that would become a much more reasonable suggestion. But we have a lot of different varied surfaces to cover. The technique we covered involved a single plane catching the footage, observing the plane from this camera, working on it, and then viewing it from the moving camera again. This has a lot of varied surfaces. Rather than catch it on a plane, we're going to catch it on geometry. And now you're going to see why the context model being split into layers was so important. We're going to set up image planes with cameras, but then we're going to swap the geometry. Let's stop the footage, pull back here, and we'll use this merge to line things up. So here's our cinema area. So we need to capture the front faces, the top faces, and then also this face here. So we're going to set up 3 cameras. We're just going to place them along here. And we're going to name them. It's going to be cam, crane, top. Cam, crane, front, which is what I'm going to call this side, the front facing the site. And then to make that very clear, we're going to call this cam, crane, Nord. And that's going to represent the facade with the Nordstrom sign. we're going to add in a replace material. And I spoke earlier about a visual organization for this. This stepping is going to be very important because we're going to do the same thing and pull these lines over here to the right. Everything moves across but down one each time, and then it's going to become very visually clear where to get things from or which one to go back to edit. We're going to connect each of these. Then we'll add all of these to the merge. Right now they're all going to be in the same place over here. So I'm going to start by moving cam crane top. I think I want to rotate this to -90 so that we get a nice top-down view of this area. Now, rather than place the image plane where we want to catch the footage, what we're going to do is push the image plane through the footage. So the depth of our image plane is going to sit underneath the geometry, and we want to look at this and make sure that this is capturing what we need. This looks reasonably close, but we'll check this shortly. Now we get the other cameras into place too. So I'm just going to take the X value from these to get them in a similar area. Take the Z value. So these are all in the same place. The front, we'll turn this way. We're going to drop it to only see the front of these. Can also angle it because we're catching a slight bit of this. Sometimes it helps to turn it down slightly. We're going to push our image plane right through to the back. So now the third one, it's going to be like this too. I'm going to drop it down here. Now, I guess one thing to point out, if you were very organized, if you knew exactly which surfaces you needed to project onto, you can set these cameras up in Max. If you find these controls a little bit fiddly, because you can import static cameras, there's no harm doing it like that. We're going to keep everything in Fusion. We're going to push the image plane behind. So one thing you'll notice here, this camera, if we look straight through it now, the background building would be obscured by the foreground. A mistake that I've made is this is all one object. So what we could do is go back into Max and re-export the FBX for just this back building. It's probably the better way to do it. So give me just a second. I'm going to go into Max and I'm going to break this FBX up into two separate objects. Okay, so now we have this Max file, and we're going to detach these. Go to Edit Poly, detach as Nordstrom, and then this one, I'm going to detach as Westfield. And while we're here, you may also notice that the ground actually slopes. There are some steps up here, so we're going to incorporate that in our model as well. It's going to save us some time and effort. Choose a spline, set to auto grid, and create that there, pull this across. I'm going to open Google Earth. We're going to get ourselves down to Century City. We're going to find that staircase. What we're going to note is the elevation here is 273 feet, and the elevation here is 283 feet. So that is a 10-foot increase from the ground to the slope. Ground also seems to slope up here, just a touch. And all of this goes up by 10 feet. Now that we've added that height, you can see that it doesn't align with the camera, so we can pull this closer to us, start to modify the geometry so that it makes sense. And now before extruding this, what you want to do is jump to the end frame, make sure it's still in the same place, which this is. Everything lines up, which means we've done it correctly. Now you can extrude this. We're going to extrude it up just to get some splines and edit poly. We're going to take these straight edges and we're just going to extrude them straight across. And we can delete these. These two edges come straight down over this one and this one across. Make them planar. Make them planar in the Z as well, and we'll pull them down to match. This area looks a little bit too low. I'm going to pick this up just slightly. And we can delete this polygon along the front. So this now feels pretty good. And we can jump back to the first frame, and everything still lines up, follows where it should. We may need this area here. See the crane at the start here? Actually passes over this second story layer. So we're going to quickly model that as well. That's very simple. We'll do that as part of the steps. We're going to pull this up to here and then pull that back along here. And this, I just want to pull this back so that we have enough, just to make sure that crane has somewhere to go. Okay, so we have some new geometry to export. So we export selected. New Nordstrom and stairs. And okay. So now back to Fusion. I'm going to take a look at the geometry we have here. Our shopping mall is what we want to replace. We're going to replace this with 3. We can do File, Import, FBX Scene. We're going to bring in our geometry. And again, remember the scale file units 0.01. What that's going to give us is our camera, geometry, and the merge. So now we have one Nordstrom building, the steps in the middle part, and this bit. So for convenience's sake, I'm going to use a separate merge 3D for these, so that these can become one. And we can safely delete this one. So geometry-wise, we know that we need one which is everything for the top down, including the ground plane. Then the front, we also need everything for that, including the ground plane, the stairs. But then for this one, we don't want this Westfield building. We just want the front face of Nordstrom. So we'll create another merge 3D here, and we'll skip the Westfield. That will allow us to break that more easily. What we can do with this one as well, we can add the ground plane into it too. I'll move this up here. It's easier. And then this merge 3D comes into here to join everything. So now we're creating different clusters where this cluster is every building, and then every building goes to the ground plane. This is just our new area. And then this is just these buildings and the ground plane. So we have everything we need now. Back to our Merge 3D. We'll still use this one to line up all the cameras. And I think we have everything we need now. And so now we're going to project the footage and catch it onto this geometry. All of our image planes are further out, so they're not going to get in the way of anything we need to do, but it's good that they're there to catch anything that goes beyond the geometry we have. And so if we add a Merge 3D here after the camera and add all this geometry, then this replace material feeding into the merge is going to start doubling up on geometry. We're going to nudge these over slightly. And then we're going to add our Merge 3D here. So this comes down, and this is where we have our slight breakaway. So this first one with the top view, we want everything in that. If you click Alt, then you can create a breakpoint. This is helpful for organization. This node doesn't do anything. It just helps you visually organize. So we're going to follow the same kind of pattern down here. Each of these is going to pipe into a Merge 3D, and then they're going to have the appropriate geometry brought into them. So this camera is the front face, which doesn't see anything else, but we don't want this building here. We only want all of the new development and the ground plane. So we're going to make a new Merge 3D for that. Probably the best way to do that, that's this residential building. We'll slide this over. We'll make a new Merge 3D, and instead of this being here, we'll attach it here. Then we have a Merge 3D here. We add the ground plane to it. So now we have everything except for this residential building, which is what we need for this one. And then for the final one, so I can get this angle, we've already created what we need here. This can go into there. We'll create a pipe node, and we'll pull it over there. So now we have this camera with everything it needs, this camera with everything it needs, and this one with the same. So we have what we need here, and now same way we used the replace material here. And so what we need to do is get a replace material after the geometry. So we're using the replace material here basically as a pass-through, just to see what's going on. We don't actually need it, so we're going to add a little control point for each of these, and we're just going to delete these replace materials. Pull them down here to keep it tidy. And the replace materials actually need to go after these merges. So now all of this geometry is ready to have its material replaced. Now we can come down to this merge, which is fed by the camera, which is projecting the footage. Add another control point here. And add each of these merges in a row. Now this first merge, we feed this into the scene input, and then we feed the camera and the footage. And now all of a sudden, all of our geometry is catching the footage. And we can play this sequence back, and you can see we have mostly stability. We still have the shaking problem that was identified in the other area. We're still going to need to fix that, doing the same techniques. That's why it's often better to make sure that your track is clean. The more things that you have to fix, then the more work you're creating for yourself. It is possible to get a perfect track where you don't need to do any of this fixing. Either way, we have a reasonably stable projection on the area that we need. I'm going to feed this into each of these, and then feed these into. And then we're going to render from each of them. They're supposed to look close together. Let me pull them apart. And again, the same naming convention: crane top, crane front, crane node. And as we pipe this into each of these renderers, we change the camera to cam crane top. So now we have a top-down projection of the entire sequence playing through. So if we play this through, I think our top-down is pretty good. We have good clean areas to paint over. And what we'll be doing with this one, so there's this patch here, which is clean and doesn't have grain over it, and the same here, and we'll use that to cover this area. Next one, grain front. Now this is kind of crazy looking, but ultimately it has what we need, which is these front faces here. Now all this is being rendered at 1920 by 1080. I think that's going to be fine. What you want to make sure is that at 100%, that there's still some degree of softness to it. 100% on this one, it's a lot of softness. And then this one, we have a very clean shot in front of the Nordstrom building. Okay, now we're going to set these up ready to paint. Same thing we did before. It's a wireless link, it's a replace material, it's a merge, and then we render full resolution and then merge it back over this. So we're going to create a wireless link. Now I like to show the tile picture on these just because it becomes very obvious which one the wireless link is. I'm going to copy this now. And then each of these wireless links will drag the render input. Now I can move these over here. Just a little bit more room. So we have our wireless links over here, where we're going to do our painting and art fixes. So at the top, the front, and the Nordstrom. Now to project these back into the scene, we're going to need to use a slightly different technique. For the previous one, our material was simply replaced with the full extent of the plane, and this plane already had a UV map, so it lined up to it perfectly. We didn't actually project this, we just placed it on as a material. It worked because of how the image plane was set up with the camera. We're going to need to project these back onto the geometry, much the same way that we did this initial area here to get these plates to work on. So we're going to need to make a copy of each of our cameras. This is going to go in as the image input for each of them, and we're going to check on camera projection for every one of them, so that now we can project this footage out from this camera obviously being our top down. So right now it's projecting it back out onto an image plane. So instead of a replaced material here, we just want to pull this same geometry that was used down into a merge 3D. So we create a merge 3D. We want to take our geometry, and then we're going to do a merge 3D here to render from the correct camera. So if we turn lights on, you can see that we've projected our top-down footage back onto the geometry, and now we've merged in the correct render camera, and we're going to be able to do a render of 3D. So we render from this viewpoint, and we have this ready to overlay. Now if we do a merge, we've got a bit of an issue. with masks. So we need to create some transparency around this. And we also don't want to include these stretched portions because we're only looking from top down. We're only interested in the top facing areas. So one simple way to create a mask for this, we take this camera, we duplicate it, and create a background with the same resolution as this. Going to make this white in the image plane. And we're going to duplicate all of this. And this renderer 3D gives us a white mask. We can turn this into a bitmap. Channel luminance. Now we can use that as a mask. So we've done this, and we have a mask for just what we need, but we still have these other areas. As we paint out, only the bits which get painted we're going to feed into this mask. So this mask will eventually become tighter. Let's get started with the paint out. Okay, so we're going to dive into the actual painting process and remove all of this. First, what we're going to want to do, we have the footage coming through here, but because we don't want to recalculate all of this every time, we're going to start running out of memory. So we're going to cache these to disk. Fusion 17 now, it works much better than it did before. You set your file path, press OK, and then play the footage through. So while this is going, this is obviously calculating very slowly because it's rendering everything through here. You can actually see on this little diagram here when nodes are loading and calculating. You can see that by the end of the cache, we've used up 25 gigabytes of memory. But now because this has been cached to disk, we can purge this, completely free up our machine of memory, but press play, and it still plays back in real time. So we're going to do this for all three of these: crane top, crane front, and crane node. Goes without saying that you want to be caching to a solid state drive here. What this allows you to do is continue to work from a network location, because you can bring in your source footage and immediately set up a local cache. And then after every stage where we won't be going back to edit anything that's been used to set up crane top, that's now fixed and this is locked for us to paint on. So at each of these points you can then set up the cache that you need. So we're totally cached here, and you can see we're using 87 gigabytes of memory, and we can happily purge that. And so long as we only preview from this cache down, we can play these back in real time, and we use 2.5 gigabytes of memory. So now we are good to go. Stop this. First, we're going to work on crane top. I'm going to leave ourselves a lot of room here. Move all of this over. We are going to need it. I'm going to take this mask area over as well. We need to create a fair bit of room here too. So what I've done here, I've also cached the end of this one, because as we preview here, we're going to want to make sure we're not recalculating all of this again every frame. The way that we're going to remove this crane is by using time stretches to freeze time at various points in the footage. As you can see at frame 0, plaza here is pretty clear. This is clear, but the crane is covering the car park. By frame 85, the car park is nice and clear, plaza is covered, and by the end, that's what gets us the most road to work with. So we're going to set up 3 time stretches. One at 0, one at frame 80, and then one at frame 130. I'm going to pipe this into each of them. Now each of these time stretches has a point where it's clean. Now, our general approach for this is going to be a bit messy. I'm going to paint quite roughly and make sure it's being projected, and then it's going to create new things to fix along the way, and we will observe them, adapt and make notes and catch them as they come. The first one I want to work on is actually the 80 to get the top of the Westfield here. So I'm just going to shuffle the order of these. We're going to create a merge, bring this footage in as the background, but this time stretched in as the foreground. And then create a mask paint. And this mask paint works pretty much the same as the paint tool. Make sure that you're on the stroke tool and that the stroke is set to all frames. And then we can go to frame 0 and we can paint this out. What we'll do is we'll paint it out of this terrace too, and let's remove it from this lower area. This is an example of where I said we'll just make some mistakes and fix them as we go. You can see that doesn't align very well, but at least we're starting to cover things up. And because of the breaking in perspective, we're going to want to paint this over the whole upper car area. Same here. Now you can look at the mask paint. You can see the mask's kind of messy, so we'll just fill in these darker areas here, make sure the mask is clean. So now that this is masked out, we're going to want to do the same thing we did here and add a color curves. And drop the alpha right down to 0. And that way this is over transparency. Then we have a merge here after the wireless link. And this is set to subtractive. And when we come down here for the renderer, we're obviously rendering everything. So when we come down here with the renderer, we're obviously rendering everything. And as we merge this over the top, we need to create a mask, so only the new bits are being applied. So go up here to this mask area, make this fully white, add a merge, and what we're going to do is we're going to create an alpha mask from this. Because this is already set up with that as an alpha 0, the mask comes through reading the alpha fine. This merge here, white goes in the foreground, and the mask applies on top. And then this gets projected through to generate a mask which follows what we've done with the painting. Now, one thing you'll notice is while this stretching is okay because it's pulling the colors through and everything's bleeding together, we don't want that in the mask. So in the camera settings, you can change the projection mode from ambient light to just light. And what that will do is it will allow the geometry to cast a shadow. Now that's not always desirable because you can see here that that's actually got a darker patch. So I'm going to do this in a different way. We're going to set this back to ambient light. We're going to make sure that our mask comes through as close to the original painted mask as possible. And then we're going to tidy that up another way. The thing I forgot to do here, we need to add a bitmap mask and turn this luminance into an alpha channel. And then once we add this here, now only the area that we painted is being applied. So there's some perspective issues and some transforms, and we'll get to those in a minute. For now, what we want to address is the masking of these vertical surfaces. So one thing you can do with this renderer, because this is rendering a 3D scene and it can read all the geometry, we can extract the normals from it. We're going to add a channel booleans. So we're going to add a channel booleans, and we're going to pull the normals through. The X normal, Y normal, and Z normal. So now we have a normal map. Now we can add a bitmap to this. Take the channel red to get to the right faces, green, which is mostly top faces, and then blue, which is turning away from the camera. So we're going to use the green channel. You can literally just pull this up here, pull this up to make a very high contrast mask. Now this might have issues, it might not be desirable, but we can combine this with other techniques to create a much cleaner mask. If the camera moves a lot, enough where the normals will actually change, you'll have to check this over the length of the sequence. Fortunately, because our shot rotates and doesn't move in any significant amount, we can actually get away with using this. So if I add this bitmap here, and then add this one to it, we can use a paint mode of minimum. And what that will do is it will essentially subtract this one from the base one, given there's only the top surfaces. Now when we apply this here, we've removed those front faces. Now we're going to be removing this section of crane, and we're going to be fixing this area, but we're going to do that with the other projections. So one thing we do need to fix now is the transformation. This has been shifted quite far along, and there's also the shake in the footage that we need to address. We take this and play this through. So we can see we missed a bit with the crane, and we definitely need to track. So the shake matches. Let's bring it here for the worst offender. We'll quickly paint this in. Let's get as much of that as possible. We don't need that area. Let's check that mask. Let's make sure there are no holes. And so the tracking, we're going to do that the same way. So right now, do that same way we did the other one. We're going to add the tracker. We're going to pick a point which follows our perspective and also the shake without something like the crane passing in front of it. So it looks like this car here is probably a good one to use. We'll set that to frame 0. Take the tracker point that was added. And we're going to track forward from current time. So that has captured all of the shake and all of the drift that we need to follow. So, same way that this was set up, this color curves now comes into this tracker. This merge should actually come after the track. So I'm going to take this now this merge So this merge, because it's masked on this one, we had it after the tracker, but because we have a mask that we want to follow the shake to, we're going to keep this merge in front of the tracker. So that goes into foreground, and then the tracker is set to match move mode. And then this tracker is what comes into this merge here. And don't forget to set the tracker to subtractive mode as well to get rid of that alpha fringing. So now we have our new locked paint, which follows the shake and follows the drift of the footage while being free of crane. The bitmap mask here, we're going to want this to follow the shape as well. So if you output the tracker into it, it's the same mask, but now the mask shakes appropriately. So we're going to want that because if the mask was stable and the footage was shaking, you may see some slight drifting of pixels. So the next thing to do is line this up a little bit nicer because we do move a lot. And that is simply a transform before the merge. So looking at it in top down, it obviously does not work down here. This whole bottom area and plaza is going to need a different track. So I'm going to go into this mask paint. I'm just going to remove all of this. I need to do this differently. So one section at a time is going to be best. I got a little bit greedy there. Let's just bring that wall into a tight version. I'm going to keep the upper part of this wall in. Looks like we need a little bit more crane fixing there. But what we have looks pretty stable. So I'm going to keep going and doing this, and I'll jump in with any insight, but by and large, it's working patch by patch. You're going to be painting it where needed and fixing things as we go. So, on to the next patch. This is pretty good for all the Westfield area. We don't really need to use source AT for anything else. Let's tidy this up a little bit. This color curve should come over here. All the masks down here. It gives a bit more room down below. Then move this over. We're now at the stage where we've basically covered every single technique that is required. We've covered freezing time at a specific point, using that to cover something up. We've covered painting, and we've covered bringing in additional source images or footage to lay over the top. Everything else is a repeat of those techniques in different ways. I'm gonna fast forward through this next section where I show the remaining work on the top down. And then after that, I'm going to jump to the final file and cover each one of these pieces as we go through. So here we're using the next moment in time that's frozen and starting to paint a mask out over the top of the plaza and the upper seating area. And then we need to check that. There's the wobble. So we track the wobble and ensure that the patch is as stable as it can be. One of the things we hit here is that because the lower level and the upper level are at different heights, the 3D model is not completely accurate. And so they actually don't match up with each other perfectly. So I broke this up into two patches. Next up, I'm going to work on painting up the road. So I pick the time stretch where the road is most exposed. And then this is your standard clone stamping to clean up the crane and the traffic and cars. And then we track it on a point which is stable and exposed, and then mask the whole thing in. So we have the road nice and clean. We've covered about an hour's worth of work in the Fusion document. To finish a shot like this, it needs a full 8-hour day, if not a little bit longer. And you do not need to watch me for another 7 hours of doing this. So I'm going to jump into the finished document. So here we are in the finished document. I just have this on the first frame. You can see that what we've done here, this is the original footage on the right, and this is the footage that we've worked up on the left. What you can see is we've repaired this whole Nordstrom, we've patched in the road, cleaned up the front of the store, removed the crane from the top, and I'm not going to play this in real time in the Fusion document, but this is fairly clean as the sequence goes through. Some other areas which we've worked as well. We jumped to frame 130. You can see that we've also cleaned up the crane that passes over this building, repaired the base here, because when the CG building goes on top, all of this and the crane was sticking out from the side of it. We didn't need to clean up this one because this is entirely covered by the 3D render, but we did need to clean up a little bit at the base where this yellow construction signage sticks out of the side. And as we pan over here as well, you can see the results of our cleaning up. This isn't perfect. I could have done a better job with some of this. When I cover everything that was done here, I'll go into the areas which I feel were slightly less successful than others. So here's what our finished document looks like. It's fairly big and there's a lot going on, but you can see how that logic as to organization starts to make itself very apparent. You come in here, there's a description of what each one of these things does. This one is the road, the residential upper, residential lower, residential flat, so the flat bit on the top, and another car park. These last two, these are fixes which I did, which I'll go into why I needed those. I got a bit lazy and didn't label them. And so the logic for all of this is the same. This first camera, as you remember, we used the image plane in the camera to project onto. So this is a replaced material and it goes straight into a merge and a render. These ones were projected onto 3D geometry. So we merged the 3D geometry back in, then replaced the material, and then render from those. You can tell the difference by the additional node on top. And then because all of these are single nodes, we know that all of these are image planes. And following that logic, we can zoom out here and immediately at a glance, I can tell that these ones project onto geometry, these ones and this one do not. Finding where each of these go as well, I made sure to keep all of these pipes straight so that we can follow them along and we can pinpoint the exact moment that they're in use. This was the point where we left off, the crane top. So as you can see, we have the time stretch, the transform, the merge, and the track, which was the first one we did. I'll just jump into each of these. So this was painting up the car park on the roof. The next one was painting up the plaza and the area above. Then there was another patch that was done in the time lapse. And then this was painting up the road. So the results of this area can now be seen on the right. This was probably the most significant patch. It's always good to start with the area which is going to cover the most. When you export this, there's edges of the masks which aren't clean, and there's a little bit of crane sliding over things. Some of these later ones, these setups, they're about fixing tiny little patches and filling in gaps. So to jump into crane front, which we didn't cover in the earlier section, this is handling the front of the store. And then we have this other section, which is handling the front of the Nordstrom building. Again, this is the same thing in the previous one. We have a time stretch, freezes time, transform it to move it, we retouch it, and then we merge it over transparency with this is using a polygon mask, which you simply draw. And then this one is using a painted mask, which you brush in. Those are both tracked and then they're added to the merge. The mask used to apply them over the footage is also generated, and then both of these are rendered. So this render 3D renders it from this angle, and then to avoid the stretching we get from working in perspective, we're also rendering the black and white mask. This one applied over the footage. Now you can see we're starting to fill in many more gaps. There's a few areas on the sidewalk here where you can still see crane. There are a few things in motion which were leaning slightly out. One important thing to note about this as well is that after each section, which I didn't include in the earlier parts of the video, I plugged it into an output node and rendered the full sequence out. It's really important to do this to check it in motion. You can review your full sequence, you can zoom in on areas in DJV Viewer, you can make notes about what still needs cleaning up, and then the next time you get in the Fusion document, you can mostly work with a static single frame. So that's where we were. So the next one along is the crane Nord, which was the front face of this Nordstrom building here. This was more required on frame 130 when the crane passes fully in front. Technique for this, exactly the same as the others. We time stretch to take frame 40 before the crane hit anything. We merge that over transparency with a simple mask to cover all the areas we need. Slight color correction needed, and then it was tracked and applied back over. Same again with the black and white mask, and then both the fixed footage and the mask were then rendered. And to apply that over the footage, we have this. So one thing you'll notice on this one, which I didn't take into account, and I didn't actually fix in this, but would be done with another patch, is that the glazing at the base of the Nordstrom building is set back from this face, and the 3D model I was using to project didn't account for that. It steps back and the perspective breaks the angles of it. I decided to leave it like that because it's not really noticeable in the final shot. You have to know that you're looking for it. So long as it looks clean and it's stable, then we're good to go. So the next section that I did, this static start, this was a way to fix a few little patches. I was trying a new thing here. What static start is, it's simply a copy of the tracked camera, except all of the keyframes have been deleted. So the camera is static in the initial position. And what that means is the first frame looks correct. And then the last frame, we see this stretch version. This is cached to disk. So I'll can actually play this sequence so that you can see it. So this is what happens when you project onto geometry from a static camera. You can see anything that doesn't have geometry to project onto slides and drifts away. But because we have geometry for this building here and many of this area, this actually ends up very stable. You can see that it tracks onto it. This is also a good way to see errors in your 3D modeling, because if you have errors in your 3D model and things aren't in the right place, they bend away. Like this area is not correct in my model. It's a bit too late to fix it. You can see how bending highlights areas which aren't quite refined enough. You can see how with this edge here, there's this like slight color shift, which means that my model was not perfectly accurate. You can also see how this footage actually gets closer to the edge of this 3D model, which means in perspective, it wasn't quite in the right place. That's not something we really need to be concerned about. It's not an issue. I just thought it'd be interesting to show. And so obviously using this static start, you can see how with a little bit of retouching, you can get patches out and you can pull things from it to then reapply over the base. Back to frame 0. And so what was done here, we took frame 80, which is this one, which I felt was a good middle ground for what we wanted to do. Painted a little bit on it, just a little bit of retouching here. And the reason for that is this arm of the crane, you can see moves over this front face. With that off, you can see that there. So this was turned into a static retouched image. It was tracked, it was transformed, and then it was merged back in. One other thing we did with this one as well, there's a mask of this area, and this polygon mask is still the video. And what that's doing is because I painted all of this area in with a static frame, we lost all animation, and these people were standing still and this car was completely still. It was starting to look a little bit bare. So I used this area, which doesn't have any crane pass in front of it, right from the first frame, to keep these people walking, and then it keeps this car in as well. And so you can see how I animated the mask here. But because the camera doesn't move and this area is pretty well locked, we're not really doing rotoscoping. It's a fairly straightforward keyframed polygon mask. And the way to do this kind of thing, when you make a polygon mask, it's ready to be animated straight away. So if you draw the mask at frame 0 and then jump to frame 130 and move all of these points, it will naturally tween between them. So then you would pick the middle frame and make any adjustments required. And then if you still need to, you go halfway between the first and the middle, or the middle and the last, and you add in another keyframe. And this way it keeps your keyframes as minimal as possible. So that was to bring this motion back in, these people and the car, and then this was to add the static footage back on. And you can see this was tracked so that the wobble catches. Then all of this was fed into a black and white mask, and both of them were rendered from the moving camera. So the final result of that looks like this. And compared to the one before it, there's not much changed on this frame, but when you get to frame 80, you can see that on the source footage, these people were static. This lamppost was bending, the car had a strange masking thing. So all of this is now in motion. And then the portion of the crane which passed over this is visible in these areas. And now that we're using the full patch, you can see that this is much tidier. Like, it doesn't have this hard line and it doesn't have this hard edge where the projection from the top is catching on this surface below it. So overall, this area feels much more natural now. And this is kind of the general philosophy for how you approach a document like this. You add a big patch first, you export it, you see the areas where that patch starts to fall apart, and add new patches over the top of it. Sometimes it's not worth trying to refine it, but a lot of these were refined as I went. So it is important to point out, these masks, I didn't get them right first time. I drew them, I animated them, I exported it, and it didn't quite cover them. There was a bit of ghosting. The car wasn't quite perfectly matched to this. So I was able to come back in the document, identify the exact point where I'd done it, and then refine those masks and get them a little bit tidier. You will not get this kind of right on your first go. You're going to need to export, review, step back into the document, refine it, export, review, and you'll do this, 5 or 6 times in a day. So that was the static camera. The next one is one for the road. This one, we've gone back to the idea of the image plane camera. So road, let's look at this merge here. So this is our 3D scene. There is a lot going on in it. Our road camera is this one, which points straight down in front of the target building. So we play this through. You can see we've got the same thing going on where all of the ground plane is completely locked because the plane is on the surface, and then any additional perspective or objects kind of passes through the top of it. And so if you were working on a much more involved shot, if you needed to take cars from somewhere, if you needed to take moving elements from one piece of footage and apply them somewhere else, this is how you would do it. You can mask something like this out, transform it, rotate it, apply it back over another piece of footage. You can do some really kind of interesting and creative things. One thing to look out for is perspective is visible. So if you took this car and rotated it 180 degrees, it would probably look totally crazy. So you do have to be quite selective with what you use to do that. So off to the area where we did this, to this road. And what was done here was just a big painting session. Just a lot of retouching, clone stamping to completely cover up this area. And then this was masked out to create an area of transparency. So we replaced the material on the image plane. I zoom in a little bit off because this camera was at too large a scale. And then we merge in the render camera and then render from there. And because this was done over transparency, we have a nice clean alpha already. This is a very, very clean way of doing this, where you have kind of minimal nodes. This is a very, very simple paint exercise. So onto the next one. This is the car park. So this is like the lower section of the Nordstrom face where the car park entry is. If you remember from the previous stage of this, there was a lot of distortion and kind of awkward bits happening down here. So what we did here, we took the time stretch, we took the last frame when this is completely exposed, we tracked it very simply to the base, picked a point so that we could get the wobble and the shake, and then this was masked over the top using a simple polygon mask. This was then merged onto transparency and simply rendered and dropped over the top. For this one, because I knew I was going to need to replace this building anyway, I let this mask just extend over the side, knowing full well that one of these next merges is going to tidy that up for me. If you think in layers and think about working from a base and then adding smaller and smaller patches on top of it, you can save yourself a lot of time, because if I had got this edge perfect, I'd have needed to get another perfect edge in this building over the top. And it increases the chance of you having edges which kind of dance and expose like single pixel brands. So to switch that on and off, you can see what we did there. The perspective is slightly off on this and it gradually drifts into place by the last frame, because we're using the last frame, and it's a little bit soft as well, but on the whole it looks pretty good. Next up, we've got Resi Upper. This was the upper section of that residential building. By frame 130, has a crane pass in front of it. The camera for this one is this one here, if you can see it. The zoom's a little sensitive. It's this camera here, which points at this face of the building here. There's another one below here, and then there's another one up top which is pointing down onto these surfaces. So standard thing again, we took a time speed, we isolated a moment where as much of this was exposed as possible, we tracked it, we merged it with a polygon mask over the top of the original. Then this was merged over transparency, material was replaced, it was rendered as a patch, and then the patch was applied over the top. So before and after, we have this. So you can see it breaks here. I knew I was going to do a patch for these anyway, so I wasn't too concerned about this. Again, same thing with the Nordstrom building. The cleanest way to do this was to extend the patch below where I needed and then add another patch on to tidy it all up. Next up, we have the lower section of the very same building. Again, time stretch, tracker, merge, and what we get is a nice clean patch of the entire facade of that building. We come down to the render, we're rendering it on transparency again like this, and then that's the bottom patch laid over. Switch that off and on. So this one's also handling the construction hoarding which sticks out onto the left, which, because the CG building follows this line just here, this lower section's fine because there's a CG podium. So that's going to cover all of that up, but we did need to bring this down quite low just to catch the edge of this. So now that feels nice and clean. Now the next bit to do is the tops of these, which is going to tie both of these patches together. This one required a little bit more. I broke this off into two. There was the upper patch and then the lower patch. Because they're at different heights, they drifted slightly independently. Because I used a single image plane for this, only this lower one is actually stable and this top one moves. I didn't want to set up two separate cameras for this, and because this is moving in a very standard linear direction, I just decided I would track it and replace this patch. It's only really in the back half that you need this anyway, and then over to the last frame. So here we've got the lower section tracked and the lower section merged. And then here we have a different source frame. We've transformed them, tracked them both, and we're merging that one onto this. So now we have two nice clean patches and then some masks where we create polygon masks for each of these. And then we combine the masks into one. This is all keyframed. And then these are rendered by themselves. Again, because we're using transparency, there's no additional masking required. And these will just drop straight over the top. So now we've tidied up those patches, covered up the crane, and we have the top, the middle, and the lower section done. There are a couple of small errors you can see. This here on the right, always remind yourself where the CG is going to go and use it as much as possible. I didn't need to clean this edge up, I did need to clean this one. There are other parts of this where you can see this CG comes right up here on the edge of this. This line only becomes visible towards the end of the shot and it's otherwise completely covered up. So I didn't concern myself with being too precise on this. It's one of the benefits of handling everything in a shot yourself, is that you know exactly what you can and can't get away with. Now this section, this is the car park that is around the left-hand side. Again, the same techniques. We time stretch, we take frame 0, we take frame 100, we do some retouching to paint this out. We mask this over the top of a different frame to get this lower section, paint this out a little further to make this clean, and then that's tracked and it's merged, and then we create a transparent mask for it. So it's just come down here to the render, and that's this section down here. Switch that off and on. You can see when switching it off and on, it's actually very visible, and there are some mask errors here. Where it breaks, you probably saw a bunch of mask errors up there. Once the CG's on this shot, you have to know that they're there to find them. Like, you have to really zoom in and pixel hunt to find them. And again, when this is on a TV screen and all of this is lit up and the buildings look spectacular and it's color graded and there's contrast, you can get away with quite a lot. No one is going to notice that there's a slight break in the sidewalk down here. If you did want to tidy that up, it's just about working slower and being more precise. It's about spending more time in the retouching area and the painting. It's about creating additional patches. I could put another camera above this and clean up that bit and reproject it. It would just add another one of these camera sections. And the final section, I redid the roof. I wasn't happy with how this was looking. The crane still passes over an area. We have a ton of geometry breaking apart, and I couldn't really find a good way to fix that within what I'd done. We were really hitting the limitations of projecting onto geometry. I do think that working with the image plane of a camera is a very clean way to work. I was hoping that by projecting onto the 3D model, I could do a lot more with only 3 projections. So these 3 here, I was hoping could do most of the work. But they introduced so many artifacts, I think it would have been better to, instead of using these 3, just have a separate camera for the top, a separate camera for this, a camera for the plaza, a camera for this front. It would have created more of these, but I think would have been a better way to work. So this last section, what I've done here is, it's just an image plane, camera projection, top down. The crane moves over everything. There's a little bit of movement. By and large, it's easy to compensate for. And so what we've done here, taken a time stretch at frame 130, taken a time stretch at frame 0, so that each of these 2 patches, the car park and then this outdoor dining area, have their own time stretch, and then this one. So what each of these are doing, so I'm simply tracking them and merging, and then we have a series of masks down here. So this first merge, this is a mask which covers the entire of the top of this car park area. This second merge is covering the outdoor dining area here. The third merge is covering the roof of this area here, which is where the 3D projection gave us a lot of problems. It was very hard to eliminate the crane from there without using this method. And then the last piece was a small mask over here to fix this roof line. All of those masks were added together here to create transparency, and all of these being tracked separately means that they can all move independently of one another, which is important to get them to slide under one another and match the footage below. So a slight bit of color correction added. And then to apply this over, switch that off and back on, you can see that this really cleans up all of this area here. We no longer have this double geometry, and this breaking makes this a lot smoother. There are still a couple of errors in areas. You can see that this breaks apart here, this breaks apart here. I could continue to fix these, but I made the decision that this wasn't necessary. Our CG building runs up very close to this and then it quickly goes behind it. I don't think it's massively necessary to catch every little detail like that. And then we have the final export. Here's the full file. So while this looks big and kind of complex, it's actually very quick to build the back half of it once you already have some of these things set up. So long as you have the difference between something that's projecting onto geometry and something that's projecting on an image plane, you can very easily just copy this, paste it next to it, plug this into the overall scene so you can see your camera, and then move the camera to line it up. What you can also do is, if this is getting a little bit too busy and chaotic, you can create a new 3D merge, pull this in, and then bring your camera into just this one by itself so that you can get your alignment and really check where it is against the surface of something. Like, you don't need to have all of these cameras plugged in here. I just didn't remove them as I went. If you wanted to have a unique merge below each camera so that you can check the exact positioning, that's also fine. This is more just for helping you line things up. And then once this is all copy and pasted, every other node is identical. You do not need to change it. You need to merge in the camera that we're going to render from, and then you have the output here. Over here, it's just as simple. This is a very, very simple one, this road. There was hardly anything done to it. You link the wireless link, merge it onto transparency, you have a replace material, which you pull from the node that you added here. And you pull that down into a merge 3D, which is applying the camera with a black background. And then after that, you have a renderer 3D where you need to change this to be the master camera in your scene, like the actual tracked camera. And then you have merges, which just run in a long chain. So you can add a new one of these in a couple of minutes and then just get straight to work on painting. I would say the total time I spent on this was less than a day's work. If I had my headphones on and some good music, probably about 5 to 6 hours in total. I was slowed down a little bit by trying to narrate what I was doing. One final thing I would like to add to this. Fairly early on in the video, I identified that the footage had a slight shake in it. Now, this was because the track wasn't accurate enough. And in the moment, I decided to keep that in and not retrack because I thought it would be valuable to show the act of tracking to counteract the shake and to work around it. One thing I will say, if you're working on a shot which is as extensive as this, with this much paint out required over this many different surfaces, go back and retrack the shot. It adds so much work because every single stage of this, you have to do a track. One thing it also prevents you from doing is sometimes it's good to take the first 70 frames of footage and instead of freezing that frame, you simply make frame 0 start at 70. So it plays from 0 to 70. And then it blends and then it repeats that same bit of footage. You can do this when the footage is completely flattened out, but because of that shake and reintroducing a shake into it, it simply doesn't work. If the extent of your work is going to be to paint out a helipad, retouch the road in front of something, or add a little bit of textured detail, I would not worry about a wobble or a shake, but I wished I'd retracked it many, many times during working on this shot. It would have made each of these so much simpler. The whole transform and track, making sure those got right. What you don't see here are the number of times when I exported the finished shot and it became clear that the track wasn't good enough, the track which is counteracting and stabilizing. So I had to delete these and redo them a few times. I had to pick new points to track. I had to fade things on and off, and there was quite a lot of work added, exclusively caused by the fact that that camera shakes by a couple of pixels. So best to avoid those situations. And then the thing that I haven't covered here is obviously the final shot. At this stage, what you would do, we've been using a JPEG sequence. You would now replace this with your EXR sequence. You can use a full 32-bit EXR sequence. This was shot with a red camera, so it had full dynamic range. So I brought in the 32-bit sequence and tone mapped it. Having that extra room to play with made that once this was exported and brought into the CG shot, it made color grading it much easier. While this shot is pretty well exposed as a JPEG, like this is already tone mapped to work on, I wouldn't recommend keeping a JPEG sequence throughout this whole process. You ideally want a 16-bit output from here, and then when you bring that into your actual CG overlay, then you can work that. You can also just start adding your CG onto it here, but I prefer to split this up into 2 separate Fusion documents. So this gets output to a final folder, and then it can be overwritten as many times as it needs. And then the Fusion document where you're applying your CG over the top and color grading and things, as this footage gets replaced and swapped out, it will automatically update. Keeping 2 separate Fusion documents allows someone else to work on the CG portion of the shot while you work on this, or vice versa. I've been fortunate enough that over my years at D-Box, I've had quite a few opportunities to do this technique. Every single time I've used this technique in production, by about the midway point, I've discovered much better and cleaner ways to do it. There's probably a lot left to learn about this as well. I'm by no means an expert in this. I don't use Fusion every day. This is just something which I've picked up on over time and been able to refine a little bit. I owe a large part of my ability to share with you to my experience at D-Box and working in an environment where every single project is a new opportunity to do something better. I think being in that kind of culture, pushing yourself to always improve and always look for ways that the previous work can be bettered is really important, especially as 3D artists, where we work with tools which are so malleable that the limits of them has not been met. Every time we think someone has raised the standard, it doesn't take long for someone to raise it to a level which we previously thought impossible. It's one of the things I love about working in this industry. It feels very fast-paced and exciting, and I've learned a lot from co-workers and various communities and being online and sharing tips, and I really hope that this is of use to you in some way.